Okay, students, now we are going to start with the second part of the carboxylic acid. Carboxylic acid already we have done. Okay, so each and every lecture is already done, and now we are going to do the derivatives of carboxylic acid. So don't get misunderstood as the same previous chapter. It is a new topic. We have studied carboxylic acid. From the carboxylic acid, how to derive the further things. Okay, so what are the carboxylic acid derivatives? Already we have studied in introduction. We have studied. Okay, now we are going to do about the preparation and properties of the important carboxylic acid derivatives. Okay, now let's go one by one. Here acid derivatives are, these are the some acid derivatives. Okay, so acid, from the acid only we are able to prepare. Derivatives means prepared from that. Okay, like milk derivatives will be butter. Okay, milk derivatives will be curd. That means we are all preparing the curd, butter, okay, all from the milk only. That's why they are called as a milk derivatives. So by using the carboxylic acid, we are going to prepare them. That's why they are called as a derivatives of carboxylic acid. Okay. So actually this is a font mistake. This is double bond O. Okay. And wherever you find this square, actually it is a double bond O. Okay. Now I am writing, already this we have discussed in introduction only. So there are total four derivatives. Four derivatives. This is the first derivative called as a acid chloride. What chloride? Acid chloride is the first derivative. Okay. And it is not necessary that only chlorine will be there. It can be any halogen. Therefore, then they are called as a acid halide. If in place of the chlorine, if we have something else, then it is called as what? Acid halide. Or it is called as acid chloride, or in place of the chlorine, what we can write? We can write halide. Okay. So if it is bromine, bromide, and fluorine, fluoride. Now this is acid anhydride. This total, it is a functional group only. Okay. And what it is called as acid anhydride. Acid anhydride. Okay. Now this is ester. These are the four. Okay. This is what? Ester. Understood? And next is acid amide. This is called as a simple amide also you can write, or otherwise you can write it as a acid amide also. Okay. Amide is also okay, or acid amide also okay. Understood? Now these are the total four substituents, four things derived from our main carboxylic acid. Okay. So I will try to circle out it with the red color. Okay. So this is the main criteria. From this, these are all prepared. Okay. So let me explain it on the white screen also, or whiteboard also, so that it will be clear to you. Okay. So from the acid chloride, from the carboxylic acid only, we can prepare, what are the things we can prepare? From RCOOH. Sorry. From RCOOH, what we can prepare? We can prepare the RCOX, acid halide. Okay. Then RCOO, again this will be CO. Okay. And R. So here this CO actually structure will be exactly like this. Okay. I will write the detailed structure so that you can understand it clearly. R, C double bond O, oxygen, then C double bond O, R. Okay. Next, the next one is the R, C double bond O, O, R dash. Okay. And fourth one and final one will be R, C double bond O, NH2. Okay. R, C double bond O, NH2. Is that understood? Now you should know all of their name. This is acid halide or acyl halide. This is acid anhydride. This is ester and this is amide. Okay. All of you remember this. I think you should write it in your notebook with clear notes. Okay. Okay. These are the name acid halide, acid anhydride, ester and acid amide. Now let us see the order. Their order is very important. Once you don't know the name of the functional group, then I cannot expect you to remember the order. Okay. So they all undergo nucleophilic substitution reaction. That is the basic reaction we have discussed in the carbonyl compounds. Which compounds? Carbonyl compound. Wherever you find this C double bond O, there the immediate and most important reaction is nucleophilic addition reaction. Nucleophilic addition reaction fastest in acid chloride, least in the acid amide. Okay. Highest is in acid chloride, second highest is in acid anhydride, third highest is in the esters. Okay. Nucleophilic substitution of acid and its derivatives is called as a nucleophilic addition followed by elimination. Okay. Or acyl substitution reaction, or it is called as acyl substitution reaction. Okay. Okay, after that order of the nucleophilic substitution, understood? Actually, that is addition and elimination. First, it will go for the addition, then it will go for the elimination. Okay, addition plus elimination is equal to substitution. Okay, now let us see the preparation method. Acid chloride. Okay, first we are preparing the acid chloride. As I told you, they are the derivatives of acids. So, acid only will be starting and product will be our this product acid chloride. So chlorine is must. Okay, so this technique already I told you, and again I am telling you, you can go through this video afterwards and write down it clearly. Okay, this week. Okay, so this will be the product you remembering methods. So first product will be RCOCl. So you can check here RCOCl. Second product will be SO2. Second product will be SO2. Okay. Third product is HCl. So if you write 2 to 3 times like this, nobody can beat you in organic. I can challenge that. Okay. Then PCl5. PCl5, how you will write? PCl3 and Cl and Cl. Okay. So see here how to check. POCl3. Okay. HCl. Then Cl will be attached here. So RCOCl3, RCOCl, HCl and POCl3. And if only PCl3 is there, 3 moles we have to take. 3 moles we have to take, 3 OH and P, H3PO3, and POCl will be the final product. Is that clear to all of you? Okay, now let us see the next topic, preparation method. How many preparation methods are there? 3 preparation method. Carboxylic acid when SOCl2, carboxylic acid with PCl5, carboxylic acid with the PCl3. These are the 3 options. Okay, now let's see the next preparation method. Okay, this is a structure. The another methods are hydrolysis. What is another method? Hydrolysis. This is not structure actually. It is hydrolysis. Okay. So hydrolysis also you can make it in the presence of acid or alkali also, no problem. Alkali means NaOH. Okay. Or KOH. So that time this Na will be removed with Cl and OH will be substituted here. Okay. So again you will get what? Acid properties. These are the properties of acid chloride. Okay. So acid chloride when hydrolyzed, OH will be substituted here. H will be eliminated. The other product is HCl and RCOOH will be produced. And here sodium salt will be there. Let us take it as a sodium, then sodium will be substituted, potassium, then potassium will be substituted. Okay, and now again already salt is there. Simple sodium and chlorine will be eliminated. Then this will be substituted here to produce the acid anhydride. So you need not to study separately about the acid anhydride now. Okay. Now if the same reaction carried out with ethers, what you will get? Ester as a product. Okay. So again I am revising carefully. Listen now. RCOCl preparation methods are how many? Three preparation methods. Carboxylic acid plus SOCl2, carboxylic acid plus PCl5, carboxylic acid plus PCl3. Okay. And next method is RCOCl properties. Next topic. Okay. On hydrolysis, it will give you the carboxylic acid. On hydrolysis in basic medium, it will give you the salt. On hydrolysis or reaction with the sodium salt, it will give you the anhydride. Okay. On reaction with ether, it is going to ester. So it is also utilized to produce almost all functional group. Okay. Now I will give you some questions depending on the flow chart. So like this flow chart, if you study, then it will be easy to understand. Okay. And immediately I will give you the practice also, so that organic should be easy for you all. Okay. Okay, these are the some practice questions, so that immediately after learning the concept, and you should be able to find out the answer. Okay, because after that so many reactions will be there, then you will never be able to answer if you are not able to identify the product immediately after the concept. Okay, so now first question is CH3 CH2 COOH plus PCl3. Okay, what are the other products and how many moles are to be used? That is very important question. Okay, so whenever PCl3 is there, immediately it should strike into your mind. 3 moles must be utilized. How many moles must be utilized? 3 moles must be utilized. Okay, so 3 chlorine will be substituted here. So 3 moles of CH3 CH2COCl. Okay, and then H3PO3. First answer is H3PO3, 1 mole, and here this will be 3 moles. Okay, now let us see who will answer this question properly. Okay, that means people are answering, it shows that they are understanding. Okay, so CH3 CH2 COONA, this will be what? COONA, sodium salt. Okay, and what will be the other product? HCl will be the other product. Understood? Okay, now let us see the next question. Next question, what is the functional group here? It is the functional group is ether. Ether plus acid chloride. Ether plus acid chloride. Okay. So very simple this one. This chlorine and this sodium will be eliminated. And this will be directly substituted over here. So I am writing in this direction CH3, CH2, CH2, then C double bond O, and oxygen CH2, CH3. What is the functional group name? It is ester. Okay. So this is the preparation of esters also. Okay, next SOCl2. So SOCl2, only thing chlorine will be substituted here, and SO2 will be there, and HCl. So CH3 CH2COCl, acid chloride plus SO2 plus HCl. Okay. Next, this will be acid anhydride. So CH3 CH2 C double bond O, oxygen C double bond O, and CH3. So like this, immediately if you solve the question, then easy to answer the actual questions. Okay. Okay, see next question. Next, this is about the preparation method and some more, sorry, properties. Some more properties also I am telling you here. So acid chloride plus NH3. Acid chloride plus NH3. Okay. What will be the answer? Very nice. Here NH3 should be written as like NH3 should be written as H and NH2. Okay. H and NH2. So this hydrogen and chlorine will be eliminated and ammonia will be substituted here. Okay. Then what is the product? Acid amide will be the product. Then if one more hydrogen is there, simply keep on replacing here. Both hydrogen, both hydrogen. Okay. Now what is it called as? NH2 bond NH2. Very nice. It is called as hydrazine. Okay. In the very important compounds of nucleophilic substitution in the carbonyl compound. DNP test 2,4 DNP test 2,4 dinitrophenylhydrazine. Okay. In that this hydrogen will be eliminated here. So answer will be like this. Okay. And KCN, simple potassium and chlorine will be eliminated. Acid cyanide. Acid cyanide is our product. Okay. So after noting down, let us move on to the next topic. Okay, next reduction reaction. We have done only about the nucleophilic substitution. Now, reduction reaction, very famous reaction. We have studied this reaction in the preparation of aldehyde also. Rosenman reduction. When acid halides, that is the advantage of organic. If you study one chapter perfectly, it will be repeated in the further chapters. So if you are perfect in aldehyde preparation method, automatically it will be useful. See, properties of acid halide also it is repeated. So acid halide plus H2 PDBSO4 oblique delta. Then what will be produced? Aldehyde will be produced. What will be produced? Aldehyde. Okay. So then LiAlH4. What I told you in shortcut, they may give LAH, lithium aluminium hydride. Okay. So SBH also they will give sodium borohydride. SBH is not State Bank of Hyderabad. It is sodium borohydride. Okay. What is the short form they will use? HBO. HBO means hydroboration oxidation. So like that in organic there will be some shortcuts. So don't compare it with our daily life. Okay. So LH means lithium aluminium hydride. Okay. So here you can check the product. If I am using the Rosenman reduction, I am getting aldehyde. What I am getting? I am getting the aldehyde. And if I am using lithium aluminum hydride, okay, it is giving you the alcohol and Bu, butyl, okay. Bu stands for here butyl, SN hydrogen, okay. Dibutyl tin hydride. What is the dibutyl tin hydride? Isobutyl hydride also you can say. So here also you will get aldehyde. These two are the products are same. Okay, these are the two products, same reduction reaction. We can carry out the reduction of acid halide with the help of the Rosenman reduction, lithium aluminum hydride and BuSNH. BuSNH and the Rosenman reduction will give you the aldehyde, whereas lithium aluminum hydride will reduce up to alcohols also. Okay. Now let's move on to the next one. Nucleophilic substitution reduction. Okay, and further reaction with the RCdR dash. Okay, so this is just like a Grignard reagent only. Okay, but on the both side it will be dialkyl cadmium. What it is called as? It is called as a dialkyl cadmium. What it is called as? Dialkyl cadmium is the reagent. Okay, now when it is treated with this, then simple R dash. Okay, 2 moles we have to take. How many moles we have to take? 2 moles. It will substituted on the both side. What is the product here? What is the name of this product? Okay, here the functional group produced here it is the ketone. Okay, ketone is a functional group. Now here also ketone only. But only thing here it is 2 moles are required for this and 2 moles product will be produced. What will be produced? 2 moles product will be produced. Okay. and here 1 mole product will be produced. So this is also ketone only. Okay, and if you hydrolyze them, then it will give you the first, after reacting with the 2 moles of Grignard reagent followed by hydrolysis, they will give you the alcohol. What they will give? They will give you the alcohol. That is the difference between the RCOCl with dialkyl cadmium R-MgX and hydrolysis. Okay, so this is the regarding the acid halide. Okay. So after this, we are going for the next one. Okay, Curtius reaction. This is a naming reaction. So normally it is found that in the board exam, this question will be two naming reaction will be given in 3 marks. Okay, so that means 1.5 mark will be there per naming reaction in board exam. Okay, so in that what you will do, what is the reactant, what is the product, what is the reagent, and if anything special conditions are there like alpha hydrogens are must, that also you should write and write the reaction. Okay, what are the things you should never miss in the naming reaction? What you should write, first of all, what is the reactant? Okay, and second thing, what you will write, reagent in presence of what? Okay, reagent, understood? And third thing, what is the product? Okay, and product. Then fourth thing, balanced reaction. Okay, fifth is optional. What is that? If some special conditions are there or not. Okay, special condition that will takes place in presence of alpha hydrogen, like that, moist air, dry air, like that. If there are some special condition, that also you should mention. Okay, now I will point out them like this. Curtius reaction, acid chloride give primary amines when heated with sodium azide followed by hydrolysis. So, but board exam, what you will write? Reactant, what it is? Reactant, it is acid chloride. Okay. So this I will write it with blue color pointed out. Okay. Acid chlorides are the reactant. Okay. And product is what? Amines, primary amines. Primary amines are the product. Okay, in presence of sodium azide. So reagent is sodium azide and water. Okay, so that reaction is here. And special condition is that hydrolysis should be followed afterwards. Okay, so how you will write? C, acid chloride. Okay, RCOCl when treated with sodium azide. Formula of sodium azide is NaN3. When treated with RCOCl, what it will give first? This will give you RCON3. Simple sodium and chlorine will be eliminated and N3 will be substituted here. Then after heating, this N2 will be lost and CO2 will be lost. Okay, CO2 will be lost from the water molecule and hydrogen will be substituted here. So primary amine, what is the primary amine? Okay, so the reaction is called as a Curtius rearrangement also because COCl converted into NH2. Okay, so Curtius reaction is preparation method of primary amines. Again, the same reaction will be repeated, but where it will be repeated? In the amine preparation. Everything you will study in organic minimum 2 times, in somebody's preparation, in somebody properties. Now we are studying the properties of acid chlorides. Okay, acid chloride when treated with sodium azide followed by hydrolysis gives the primary amine. That is the Curtius reaction. I think all of you will remember. You yourself can ask after some time, after 2 days, after 1 week, then it will be memorized automatically. Okay. Okay, this is an example. What is its name? Benzoic acid. What is this? Benzoic acid is first converted into benzoyl chloride. Okay, actually it is double bond here. What is it is called as a benzoyl chloride. Okay, benzoyl chloride. Okay, and what is its name? Aniline. In IUPAC name, it is very easy to write, but in commercial name, it is very difficult to remember. Okay. First, we have converted the carboxylic acid into the acid chloride, and acid chloride is further converted into primary amine. Okay. So only from here to here it is Curtius reaction. This is not Curtius reaction. This is a initially it is not Curtius reaction. Okay. It is only providing the reactant for the Curtius reaction. Okay. Now let us see the further next part. Okay, benzoyl chloride used as a benzoylating agent. Okay, for alcohols and amines. So we can use it for the amines also. We can use for the alcohols also. It is less reactive than acetyl chloride due to the minus A effect of phenyl group. See here, benzene electron also be, stronger bond. Okay, there will be stronger bond because lone pair will be here and bond pair will be here. Okay, and if the benzene is giving the electron to this, then bond will be weaker. Okay, so benzylation can be carried out in aqueous solution below 25 degrees Celsius as well as non-aqueous medium. So benzylation of amines in aqueous medium is known as a Scott-Bauman reaction. Okay, this is also naming reaction. Scott-Bauman reaction is benzylation of amines. Okay, benzylation of amines in aqueous medium is called as a Scott-Bauman reaction. Anyhow, you will study that in the preparation of amines again. Okay, benzylamine will be studied in again in the amines. Okay, so this is all about the first acid chloride. Acid chloride preparation we have studied, properties we have studied, most important naming reaction also we have practiced. Next is the acid anhydride. Okay, so acid anhydride is, sorry, here also double bond. This is the acid anhydride, R C double bond O and R C double bond O R. Okay, so the nucleophilic substitution reaction can give, first simple it is anhydride. Anhydride means water is removed. So once you add the water back, then you will get the acid again. Okay. So it is, we are simply adding the water. Okay. So once we are adding the water, that will split up into both acids again. Now if we are doing it in the presence of the base, so it will give you the carboxylic acid. What it will give? Carboxylic acid. If we are heating it with the alcohol, then carboxylic acid will be produced and ester will be produced. What will be produced? Ester. And in presence of ammonia, ammonium carbamate. What is the answer? Ammonium carbamate. If it is a primary, then primary I mean secondary, secondary. This starting only we have studied. Okay. Okay, up to here I think it is clear now. Now let's see the next slide. Ester. Okay, next acid halides, acid and derivative is ester. From preparation, we have studied this in the two places already, where in the properties of carboxylic acid, also in the properties of alcohol. The same thing is third time. Okay, it can hydrolysis can be carried out in concentrated sulfuric acid. So this is alcohol, this is carboxylic acid. So one hydrolysis, this water molecule will be removed, then our ester will be formed. So I am clearly writing it here due to some print mistake, that is the problem. Okay, H and OH, whatever it is here, then you can use even carboxylic acid plus alcohol, dichlorochromate. Okay, then also it will give you the ester. These are the two preparation method by reaction with the carboxylic acid and alcohol. Okay, now let's see the next part. From acid, chloride and alcohol. Only thing here, if it is a carboxylic acid, OH will be there. Up to here it is common. Oh, sorry. Okay, up to here it is common. Okay, in alcohol, carboxylic acid, it is OH. Okay. So in that HOH water is removed, but here it is Cl. Cl and H, what Cl? It will be HCl will be removed and it is going to give you the ester back. Okay. Same way Cl and Na. Cl and Na will be removed, then ester will be formed. Okay. So you can use it even alcohols or you can use the sodium salt of alcohols also. Okay. Then you will get the directly ester will be prepared. Okay. This is the second preparation method. Okay. Now let's see the next one. From diazomethane. But here in this ester will be methyl esters only produced. This we have studied and the properties of carboxylic acid also. There also I told you this is going to be studied again. But only a problem is that this will give you the methyl ester only. What ester? Methyl ester only. Okay. But in this reaction, aldehyde converts into ester in presence of aluminum ethoxide. So if this presence is written and aldehydes are used, okay, then that reaction is called as a Tiskenko reaction. What it is called as? Tiskenko reaction. Okay. Okay, next nucleophilic substitution reaction. First reaction is esters undergo. Okay, esters undergo nucleophilic substitution reaction with water. This is also known as hydrolysis, which is catalyzed by acid catalyzed reaction. Also, we have studied base catalyzed reaction. Also, we have studied. Okay, already we have studied in the esters. Already we have studied. Sorry, we have studied in the carboxylic acid. Already we have studied in the esters. Okay. So now let us see the further. Okay, hydrolysis. Esters undergo nucleophilic substitution reaction. Nucleophilic substitution reaction with water. This is also catalyzed acid catalyzed. Now let us see the RCOO R dash. Here as I told you acid catalyzed. This mechanism we have done in detail in carboxylic acid preparation also, in alcohol preparation also, and it is a reversible reaction. That's why here two arrows are used. Okay. Now let's see the next one. What is the next one? Yes, next one is base catalyzed. Like that, if you respond, then automatically you will also understand in a nice way. Okay. So base catalyzed. In this base here, acid we have written H plus. Now here in the base, what we will write? Either OH minus is also sufficient as an example. If you write here NaOH, what we are writing here? NaOH, it will be sodium, and if it is KOH, this will be K plus. Okay. So alkaline hydrolysis is also known as saponification. What is saponification? Actually, preparation of the soap. Okay. Saponification means preparation of the soap is called as a saponification. Okay. And it is also reversible reaction because carboxylate ion. See, this is called as, up to here it is called as a carboxylate ion. This is stabilized by resonance. Okay. It is don't have any problem in this structure also, no problem in this structure also. That's why product is stable, so the reaction will be reversible. Okay. So non-equivalent resonating structures. Here see, number of pi bond and sigma bonds are not matching. Okay. Equivalent resonating structure and non-equivalent. Here this is negative, this is positive is not there. But here it is negative and positive. See here negative and negative. They are called as the equivalent resonating structure and non-equivalent resonating structure. Both way it is explained. Okay. So now let us see the next part. Let me clear this. Clear, clear. Okay, Claisen condensation. Now once naming reaction means again old naming reaction also you should not forget. Okay. So what in every reaction what you will remember? The reaction between two molecules of ester. Okay. So one ester should have at least special condition is at least one alpha hydrogen. Okay, catalyzed by C2H5ONA in presence of C2H5OH. Okay, So Claisen condensation. Condensation means molecule combined together. When minimum number of molecule combine together, aldol condensation. Okay, so here reactants are what? Esters. Okay, and what is the presence? In presence of sodium alkoxide, in presence of alcohol. Okay, and what is the special condition? At least one alpha hydrogen must be there. Okay, so this is the Claisen condensation. Condensation of 2 moles of ester in having at least one alpha hydrogen to form, sorry, in presence of sodium ethoxide and so ethyl alcohol solvent. Okay, that is called as a Claisen condensation. And what is the product here? It is alpha keto ester, sorry, beta keto. Very sorry, it is beta keto ester. Okay, how, what is beta keto? See, this is the functional carbon, this is alpha. Okay, this is beta keto ester. Okay, now here only I will write Claisen condensation. Claisen condensation. In everywhere you will remember minimum 3, and here we have to remember 4 things. Okay, reactant. What is the reactant here? What is the reactant here? Second thing, what are the product here? Okay, what is the presence of here? What is the presence of here? Speed up. Okay, and special condition. What is the special condition? Okay, first of all, reactants are 2 moles of, very good, ester. Okay, here I am writing the answer. It is the condensation of 2 moles of ester. Okay, 2 moles of ester to form beta keto ester. Again, it will be ester only. Beta keto ester in presence of sodium alkoxide C2H5ONA oblique C2H5OH. Okay, C2H5OH. What is the special condition? At least one alpha hydrogen is must. Okay, so this is the Claisen condensation. Is it understood? Okay, if the question comes like this, okay, the best way to read the organic as per me is Claisen condensation is reaction of dash moles of dash with at least one dash and dash in presence of dash in dash solvent to form dash. Okay, you can try and you can remember, memorize more fastest effective way. Okay, I hope all of you enjoyed the acid, halides, esters, okay, and all acid derivatives. There are 4 acid derivatives we have studied: acid halides, esters, acid anhydride, and acid amide. The order very important. That order is very important for your competition exams, and naming reactions are very important for the board exams. Okay, all of you, I think all of you like these sessions. In the forthcoming classes, we will be studying further topics. Okay, see you. Bye bye.